Thank you for being here, and yeah, despite it being so late, so really awesome that so many people are still awake. And yeah, so that's the talk title, so let's jump right into it. And it's called The Perspective from Production, so let's start with this perspective. So, hi, my name is Dennis. I'm working for 5 years at Blue Yonder now. And one of my tasks is to manage Python templates, which I used for multi-repositories. So instead of one large mono-repository, we have multiple smaller ones. And they're basically for creating services which are deployed to the cloud using Docker images. We're using those templates for around 30 developers. And we started this whole thing like 4 years ago. And I would say during this time, we had like 2 major milestones. First one was switching to the Conda ecosystem 2 years ago. And the second one was like being inside the Conda system, switching to Pixi as project manager, which we are now using for 9 months. And that's probably like the last clue you got that you know, okay, I'm talking here about yet another Python package manager. Yes, I know we have quite a lot already in the Python ecosystem, and probably you're already typing the question, okay, why don't you use UV? Why don't you use poetry? So like we have enough of those, right? And so what is bringing Pixi new to the table? And I would say if you look at Pixi and each of the feature individually, actually it's not that revolutionary. However, if you consider that you are inside the Conda environment, so like if you really love the Conda ecosystem and you want to have a really good Python package manager, which basically is an all-in-one solution, like you maybe experienced with UV recently, then Pixi is, I guess, the perfect fit for you. And I think, and today I'm trying to prove that, or basically pitch that to you. Okay, so what we're going to talking today. So I already said it's about Conda, so we are doing a quick Conda versus PyPy comparison. Then I will introduce Pixi, highlight some features, show what we had before. Then we go a bit into the DevOps direction, so talking about GitHub Actions, log files, Docker images, and so on. And lastly, we wrap this up with some of the experience we made during this 9 months of actually using it. Okay, so when I say Conda, then I would say I always get 2 kinds of reactions. So the first reaction comes from the fans, so they know what Conda is, they like the ecosystem, and they see their value. And the second one is basically said, oh no, I must not use Conda, I'm gonna get sued, so there's a whole lawsuit incoming, please go away. And this whole Anaconda drama is, yeah, I would say a bit weird in terms of documentation, communication, but I would say like the people who made Pixi, the prefix guys, made a really good blog post about this whole topic. So if you want to know the details, here's the link, please check it out. So in short, we have the company Anaconda, and it's providing channels for the Conda ecosystem, the so-called default channels, and they're basically curated by Anaconda. They provide commercial support, and depending on the type of organization, they might charge you for it. On the other hand, we have Conda Forge. This is completely open source. It's paid by sponsors. Feel free to contribute. So everyone can use it. It's hosted mainly on Anaconda, so if your company might block everything with Anaconda inside the URL, you might need to use mirrors, but there are many available, so you also don't have a single point of failure here. And then, of course, you have the installer. So obviously, if you go to Anaconda page, getting the Anaconda distribution, you get the default channels, which are from Anaconda. But for example, if you're using Pixi, Pixi comes with Conda Forge sets as default. So if you're using Pixi, you probably won't get into any legal troubles there. Okay, so, but why finally use Conda in the first place? And probably it takes another conference to get all the benefits, what you can get with Conda, and the many reasons many people use it. But I can only dive in what our reason was. And that was basically the level of isolation. So everybody knows Python virtual environments. So there you have your pip fields. You can install them. They cover all of your Python dependencies. But they actually don't cover, for example, your Python interpreter. They don't cover maybe the libraries your Python dependency actually depends on. So and this is bit of a problem if you really want a self-contained environment which behaves the exact same way locally and inside the cloud. So our first approach was basically going to the right side and using just Docker images everywhere. So not just on the cloud, but also locally. So if we run tests, we build a Docker image and run tests within it. If we want to develop, we build a Docker image, connect our local IDE to the remote interpreter inside the image, and try to develop with that setup. And there you really have a nice level of isolation, but it's really a pain to develop for because Docker images are not the fastest technology. Connecting your IDE to the image, getting the path mapping right so that you can actually do debugging. That's actually not that nice. And that's why 2 years ago, someone pitched to us Conda environments. And since those are multi-language dependencies, so you can include your Python interpreter because it's just another dependency in your Conda environment, you can include something like glibc, which is also just another environment. So it actually is pretty self-contained. Of course, you have some dependencies to outside of your environment, but they kept to a minimum. But since it's just another virtual environment, it's locally on your PC. You can just install it. It's quite fast. And really, you have all the developer friendliness which you would have with pip packages. So you get a little bit drop of isolation, I would say, but it's really worth it because like the developer experience is really nice. Okay, that means we were sold to the Conda environment. So how did we set up a template? And basically, we needed a bunch of tools to set this up. So we need a resolver to install and resolve all our dependencies. So that was Mamba. We also wanted to have one single log file to get all those multi-platforms in there. That was Conda-log. Of course, we had some kind of linting tools, which we wanted to execute on the spot. There we used pcommit, but actually that was not the only task we wanted to do. So we actually had a bunch of other tasks we wanted to somehow wrap, and therefore we used makefile because, yeah, why not? And when I heard first of Pixi, I did go through the feature, and basically it took some time, but then I realized, actually I can just use all those tools and just use Pixi instead. And that was really an eye-opener to me because like it's not just those tools, right? So like you have to make them work together. You have to build like the scripts and the glue code so that it somehow works. And with Pixi, now I just have a package manager which just does do that. Like normal documented features. So like I'm not misusing here anything. And that was really nice. So let's talk about Pixi. So Pixi is a Conda package manager solution. It's really easy to install, only one line. You don't need any prerequisites, so you don't need any pre-installed Python interpreter. I think it was inspired by Cargo and Yarn. Today you probably would say it's very similar to UV, but I think they started around the same time, so they could not be that inspired by each other. It has one log file for multiple environments and platforms. It does support task execution. It also supports PyPy on top of Conda, but it basically uses UV for that. And since it's written in Rust, it's really lightning fast in resolving and installing environments. So for people who use UV right now, it's basically the same experience. All right, then let's dive into the log file. So here I have an example how the structure of the log file looks like. And the really nice thing is, so the log file stays always up to date with your manifest file, and that could be either a PyProject toml or a Pixi toml. And when you're doing something like a task execution, it actually checks if your manifest is up to date with your log file. If that isn't the case, it will update your log file. And then it also checks if your log file is up to date with your environment. And if the environment is out of date, it will reinstall your environment. So basically, if you run a task with Pixi, your environment is always up to date, and you literally never need to manually install your environment because Pixi is taking care of that. Also, a feature I really like is the multiple environments, and basically there I have two use cases. So the first, I call it hierarchical environments. So let's say you have like your production code. Here we have fast API in our application. You have then on top a testing framework like PyTest, and you maybe have some dependencies you only need locally for debugging, in this case IPython. And of course, you want them to be resolved together, meaning the fast API version inside my pod environment needs to be the exact same fast API version inside my dev environment. And actually, you can do that. So on the top, we are defining the features here, and on the bottom, we are mapping for each environment the features. So prod gets the prod feature, test gets the prod and the test feature, and the default one gets prod, test, and dev features. And with this and then with the solve group, so calling this the same solve group, actually tells Pixi, yes, this needs to be resolved together. And that's why all those shared dependencies inside this environment will be the exact same ones. But you maybe have an additional use case. So let's, for example, we have this fast API app, and we want to have some very complicated step to set things up locally. So like you really need to do some fancy workflows, and for some weird reasons, you need an Airflow dark which executes all this local setup. Okay, that means you need Airflow. And of course, we could put Airflow to our dev dependencies. However, Airflow itself also has lots of dependencies. And some of these dependencies might impact your prod dependencies because they are solved together. So I really like my Airflow to be somewhere in the corner where it doesn't affect every other thing. And that's simply possible by just having a separate feature and putting it in its own environment. It doesn't have the same solve group, so it's treated completely differently, can have different versions, but everything is still resolved together, just independently inside the same log file, and then you can just run pixi run.airflow, and your complicated pre-configuration step gets done. Okay, now we're talking about DevOps, and here I like to shout out to Pavel Sverchke because he wrote several tools around Pixi, which makes my life as a template maintainer so much easier. And the first example I have here is setup Pixi. So that's GitHub Action, which basically installs Pixi, makes it available in the namespace, and installs the environment. And therefore, like writing a test action is kind of straightforward. You just check out your repository, you install Pixi, install your test environment, and then next step, you can just run Pixi run test. It's also quite fast because it uses caches. So for my use cases, I think this step only ever takes below 10 seconds. But of course, it depends on the size of your environment. Okay, one other feature I really like is this reviewing log files feature. So log files are great, but basically if you update them, so like if you resolve them, they're really a pain to review because log files can be multiple thousand lines of code. You get the diff, most of the time it's way too big to render actually inside GitHub, and you don't know as a reviewer what to do with it. And yeah, there's basically another two tools. So I put the code up there, so called Pixi diff and Pixi diff to Markdown. And this essentially summarizes the changes in the log file. So it's order them by whether it's an explicit dependency or implicit one, and also showcases the type of change. So is it a major upgrade where might introduce breaking changes, or is it just a patch upgrade where you have a big chance that everything going fine and you can just put acknowledge to it. So I really love this because before that we had nothing like this, and yeah, I mean, you reviewed log files before, right? So like, it's a pain. Okay, then speaking of Docker files, so good thing is Pixi comes with image with a pre-installed Pixi image. So I think it's in this case Debian based, and what you can do is you can copy over your application code and run a so-called shell hook. So a shell hook is basically a script which activates the environment for you. So in this case, yeah, I'm using the shell hook to get my pod environment so that I can run it inside the script. On the second line, I add the comment to run my application code. And the cool thing is now, if at the bottom, I don't need Pixi anymore to run that thing. So I can just use a bin bash and run app, and I don't need Pixi anymore for that. So like, if you are the type of person who really likes multi-stage Docker files and keeping your Docker file as minimal as possible. So basically, you can basically use this Pixi Docker file to build your application, copy over the environment and your application code inside a much smaller Docker file, and basically use that to ship it to production. So in this case, we actually don't do this because like Pixi is only like 30 megabytes big. So we basically prefer the build speed, and the less steps you have inside the Docker file, the faster it goes. And we're doing here a bit of caching trick. So we copy over first the manifest and the log files, doing the shell hook, and then after that copy over the editable application code. And the reasoning behind it is, as long as my manifest and the log file doesn't change, multiple builds can basically have here the same layers, and we save like a bit of space in our container registry. Okay, and yeah, that's all I have on DevOps. And of course, now the important question is how we made everything on, so how did we migrate there and how did it go? So basically, I'm a fan of Pixi, so I convinced my colleagues to let's use that in our template. And basically, I got through with it, merged the template, reserved a lot of time because, hey, I'm currently changing like the developer workflow for 30 developers, so stuff will break and they will be angry at me. So I blocked a bit of time in my calendar, and yeah, and then let's see what feedback I got. Yeah, so that's actually not a mistake. I really got nothing, so I just merged it, and like they didn't say anything. So I pounded them and asked, hey, yeah, there's Pixi now. What you think? So what's your experience? And then I actually got feedback. Yeah, it's a bit of anticlimactic, but I have to say, like, again, we are changing the template, so it was visible change, and nobody complained. So I have to say I'm working with Germans, right? So like nobody complaining is like a really high praise there. And I was kind of amazed because like I just get through with it. So like it was nice. Of course, we made some real experience down the road during the 9 months, and basically I put this like from 2 perspectives. So for me as a template maintainer, I can say that the template code was drastically reduced, mainly because it was less tools we used. I didn't need to somehow weirdly put them all together, because like now I was like using standard feature like that we intended to use, like that's big thing, which also means like I didn't have to write documentation for it because standard features are documented on the Pixi page. And since it was less code for me, there was also less issues, also a nice thing. And it actually improved tooling because like the summary of the log file, that was something we didn't have before. So that's basically just a statement of how much cool things are there within the Pixi community. of course, something to consider is that Pixi is not yet at version 1.0, which means so they basically can introduce breaking changes, but so far I would say it's very stable. So we had, I think, one occasion where they introduced something where we said, okay, we need to adapt our template, and then we can say to our users, okay, it's safe to go to the most recent Pixi version again. But so far, so it seems like they want to avoid this, and it was very smooth. Yeah, from a user perspective, we witnessed that onboarding was so much quicker because now we did only have one single thing to install globally. Features are officially documented, so less documentation is better documentation, at least if you don't need more documentation. Also, the install speed of environments was pretty nice. So, of course, the big change comes when you are resolving dependencies. However, that's like a GitHub action we do once a week most of the time, so that's nothing the usual user would normally do. It's also easier to contribute now to our template because everything is just a bit easier and easier to understand. So also very nice that we have now more people doing that. And of course, from time to time, I actually had to do some troubleshooting, but yeah, it was most of the time pretty straightforward. So I think like over 90% of the problems we could simply solve by cleaning the cache, delete the .pixi folder, and then yeah, reinstalling everything again. All right, I think that was already the last slide. So thank you for listening, and happy to take any questions.
Thank you so much. Like we have many questions coming up. So to get started with, how does Pixi, how does it play with custom Python package registries like Artifactory or code artifact, dev something?
Yeah, that's a good question. So we also use Artifactory in our company. So it basically has a lot of support for all those authentication methods. So for our use case, most of the time we're using netarchive files, and there's Pixi support for it. And if you're using the setup Pixi GitHub Actions, like your logins and URL from the Artifactory are basically just inputs you can additionally put in there.
Okay, so the next question is combination of questions. Can we use Pixi with virtual environments instead of Conda? And the second part is there anything that you don't like about Pixi?
Yeah, so the first one is, so instead or on top? So I didn't.
Virtual environments, can we use Pixi with virtual environments instead of Conda? VENVs.
Yeah, so I would say like Pixi is a Conda package manager. So normally you set up a project and you don't set up your environment like totally independent of the project. But again, so like Pixi is utilizing the Conda ecosystem. So I'm just referring here to Conda as an installer, and there you can use it. There's also the Pixi global feature where you can globally install tools. So if you need something globally, like maybe pre-commit, so that's totally possible.
Okay, and the second question, what do you don't
Oh,
like
sorry,
about
yeah.
Pixi?
Yeah, I mean, it's quite new, so there's nothing I would say I dislike which is already there. Of course, you always have some stuff on the roadmap which you look into it. So I'm very interested, for example, in the Pixi build feature. So that's something which probably will be interesting. For example, that you really can do this template not for hosting services, but for providing libraries, which then outputs pip wheels and Conda packages side by side. I also would like to replace the technology we have in our big mono repository with Pixi. So I think the workspace feature needs more refinement there. But yeah, so it's basically more like stuff I'm looking forward to, and I don't really have that major complaint points.
Okay, next question is specifically about Docker file example which you have used. Why does the user with ID 1100 have to be the owner of the application code? does it need to write access, and if so, why?
Let's go in there. I think, yeah, so I'm thinking I'm using the root. Yeah, so now that's, I think, something from within my company that we don't want to use the root user when running the Docker image, so that's why I'm changing users here, but it has not anything to do with the Pixi image per se.
Okay. So the next question is, does Pixi understand dependencies between multiple local development modules that are not pushed to an Artifactory repo?
That's a good question. I think it gets introduced with Pixi build. Yeah? Okay, thanks. Yeah, so I think it gets introduced, but I would say it's still in preview feature, so I'm not really sure about that. So probably check out the Pixi webpage for that.
Okay, one last question for the day. So, is the resolver speed faster or comparable to Mamba?
That's a good question. So basically, thanks. So the short answer is faster. The long answer is that basically Pixi is built by Prefix. It's a company which is founded by the person who wrote Mamba. And yeah, so basically Mamba was written in C++. Pixi was written in Rust with the experience they had with writing Mamba. So obviously Pixi is faster because it's the newer iteration.
Yeah, that's all we got. With that, thank you once again, Dennis, for sharing your valuable insights. Thank you, everyone, for interactively making this session more interactive. Thank you, everyone.
Thank you.